Hello everyone, greetings of the day, dear authors and invited guests. Welcome to the technical session 11C. Myself Prashi and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastics LLP, it is my great pleasure to welcome you to the 10th International Congress on Information and Communication Technology ICICT 2025 London, United Kingdom. The 10th edition of this conference is being organized in a hybrid mode. The physical event was held the day before yesterday in London, United Kingdom, and the virtual event is being held through Zoom from 19th to 21st of February 2025. I hope you will enjoy this knowledgeable and interactive session through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for the question and answer. On the 10th minute, I will be raising a gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any queries or updates, then you are requested to write it to me in the chat box given below. Just before we start our session, I would like to introduce you all to the chair of our session, Miss Saint Mutelo. Professor Saint Mutelo is a lecturer at the Namibia University of Science and Technology, specializing in information systems and information science. Through her academic and research contributions, she plays a key role in advancing digital transformation and data-driven decision-making in the field of informatics. We welcome you to the session, ma'am. Would you like to say a few words before we start our session?
Yes, thank you. I'm looking forward to the discussions and the presentation. Thank you.
Thank you so much, ma'am. I'll now like to introduce you all to our second session chair of this session, Dr. Tarun Kumar. He's working as assistant professor in School of Computing Science and Engineering at Albertus University, Greater Noida, worked as assistant professor in Computer Science and Engineering Department in Institute of Technology, Faridabad, also worked as deputy dean in academics. We welcome you to the session, sir.
Thank you. Thank you, ma'am.
Would you like to say a few words, sir, before we start our session?
So let's hope we get a good session, and we'll add more going forward.
Thank you so much. Thank you. Now, without wasting any time, we will start with our session. Our first presenter is Muftashul Huda, presenting the paper titled AI Enhanced Instructive Design: Insights into Constructive Learning Support for Malay Language. If you are available with us, I request you to kindly take over with your presentation, please. Sir Huda? Okay. So looks like we don't have Sir Huda right now along with us, and he will be presenting 2 papers in this session. For the second paper as well, he will be right now he is not available. We'll have to skip our second presentation also. So I'll go down to the third presentation by Farhan Mahboob, presenting a paper on the title Graphene for Qubits, a brief review. I request you, if you are available with us, kindly take over with your presentation, please.
Yeah.
Okay, sir.
See the share file?
Yes, we can see your presentation, sir, but it is not in the slideshow mode.
Is it all right now?
Yes, sir, it is all right.
Can you hear my voice?
Yes, sir, we can hear your voice as well.
All right. Should I start?
Please, yes, please.
Well, good afternoon. I am Farhan Mahboob, Associate Professor of World University of Bangladesh, and my presentation topic is the graphene, which is the future of quantum computing. As you know already that in computer, we just read about bit and bytes. Now, there is one new term is called like qubit. And for this qubit, I just want to say that this is a quantum bit that, unlike traditional bits, can exist in multiple states simultaneously due to quantum superposition. And for qubits can leverage quantum phenomena like superposition and entanglement to perform complex calculation exponentially faster than classical computers, especially in cryptography and artificial intelligence and other fields. So to understand qubits is essential for advancements in quantum technology and application. So qubits versus traditional bits, the difference is unlike the traditional bit that represent information as either 0 or 1, and qubits leverage quantum phenomena such as superposition and entanglement. These allow qubits to perform complex calculation exponentially faster, particularly in things like cryptography and artificial intelligence. Now, there is one question about what are the primary challenges in using graphing for qubits and how are the researcher addressing them. For this thing, we have to know that the understanding qubits in quantum computing, a qubit can exist in a state of 0 and 1 at the same time, enable complex computation. And for entanglement, we get that qubits can be integral, forming correlation beyond classical bits, enhancing computational capabilities. And for quantum advantages, we can get enable quantum computer to solve that problems that classical computers find intractable. Now, cutting graphic into nanoribbons to increase the band gap due to quantum confidence and is taking two graphene sheet to form bilayer graphene, where an electric field can open a tunable band gap. So the challenges in qubit implementation, there will, despite the promise of qubits, significant challenges persist in the real-world application, including maintaining quantum coherence and minimizing the environmental noise. Achieving long coherence times and high fidelity remains a critical barrier for current quantum technologies. So graphene and its potential in quantum computers, when I do the exploring of graphene qubits, so for the newcomers, for the definition of graphene, I can go with a one atom thin layer of carbon atoms forming a two-dimensional lattice structure. And for remarkable properties, it's like if I use the graphene, it exhibits high electrical conductivity, mechanical strength, and thermal properties crucial for technology. And for innovative application, potential application include quantum circuits and quantum computing system leveraging graphene properties. Future implementation, I used to work on that right now, but I just read some of the journals. Then I saw that the integration of graphene in quantum technology could lead to breakthrough in the computation power and efficiency. I just work on that right now. So as I told about the graphene's unique properties and advantage of graphene for qubits, let's go to the strength of the graphene for qubits. Why are using this one? For the scalability, the two-dimensional structure allows for seamless integration with existing semiconductor manufacturing technology. This compatibility enables the potential for scalable quantum circuits, making graphene a promising candidate for future quantum computing application. And for noise resolution and spin orbit coupling, one of the standard feature of is like spin belt qubits in graphene is their resilience to electrical and magnetic noise. This robustness from the unique electronic structure for bilayer graphene, which significantly reduce decoherence and enhance the reliability of quantum information. And for the spin orbit coupling, the facilitates spin orbit interaction, potential leading to the advantage of stable spin valley qubits that utilize both spin tails and valley degrees of freedom. Now, there is one question that what makes graphene a promising material for qubit developing in quantum computing? So graphic unique two-dimensional structure provides exceptional electrical conductivity, that higher carrier mobility and remarkable mechanical strength. This is the brief review that I just told about that the graphene from the introduction and the challenge, the recent breakthrough in bandgap modulation and software engineering and enhanced performance, integration with hexagonal boron nitrate, which is known as HBM, and electroelastic gating techniques, and development of hybrid structure and bridging material science with qubit technology. So to choose the graphene, I just use the other things to compare with them. And this is the key properties of supporting cubic application in the materials band gap comparison. So for the graphene, the band gap and the type of materials and key application in qubits, see in the left side and the pristine graphene, graphene nanoribbons, bilayer graphene, doped graphene, hexagonal boron nitrogen. I just use that the band gap is show me these things. The band gap type of materials I used are the key application in qubits. You see in the middle one and the type of material, when I use the pristine graphene, the semi-metal things is not suitable for direct cubic application without modification. And for the nanoribbons for the semiconductor, using spin qubit with tunable band gap. And bilayer graphene, I just use the semiconductor with external feed, can be used in tunable qubits due to band gap controlled by electric field. And doped graphene semiconductor or metal enhance qubit properties by introducing charge carrier. And for the hexagonal boron nitrate, white band gap metal used as a direct substrate for qubit stability. And showing the first figure in the band gap, you see that the whatever I use that in pristine graphene or graphene nanoribbons or bilayer graphene or doped graphene or hexagonal, the band gap is like 0.2 to 0.5, tunable 0 to 0.25, varies depend on dopant. And for the last one in the boron nitrate is 4.5 to 6. Here the materials I just use that to compare with other things like copper, aluminum, highly doped silicon, and highly doped germanium to compare with the graphene. You see the spin lifetime is like bigger in the copper, aluminum, and highly doped silicon or germanium. But in the graphene, we get the spin lifetime is less and the spin diffusion length is like higher. For the reference in exploring the computer graphing technology, the paper topic I use from these things, the graphing contours from coherent qubit control, bilayer graphing, and the computer devices and quantum information processing, and HBN graphing historical structure, and coherent control of a hybrid superconducting circuit made with graphing. The key outcomes is coming like this way, which is for the dots one demonstrate enhanced coherence time in graphing quantum dots. For the tunable quantum showed precise control of qubit states through bandgap modeling in bilayer graphing. And for the graphing nanostretch qubits for quantum give the significantly enhanced qubit coherence. And for the HBN is achieve greater qubit stability, which I showed in the other one that compared to the other things like copper, aluminum, germanium, that the graphene is like better than that, the spin things and the length of the things. So as I told you earlier, that the comparing other metals, the graphene unique properties is characterized by exceptional electrical conductivity, high carrier mobility, and remarkable mechanical strength, making it the ideal candidate for the next generation quantum device. The challenge I face or just working on that, I'm through with this with like 6 to 1 year. Then the challenge phase, like the zero band gap nature of graphene presents like significant challenge in achieving stable qubit state, which are essential for effective quantum computation. And for the recent in advantage that the recent efforts have focused on the band gap modulation through chemical doping and such as hexagonal boron nitrate, showing promise in improving graphene's electronic properties. Future research direction before I just go through the other papers. They are working on the direction that multidisciplinary approach involving material science, condensed matter physics, and engineering will be crucial for advancing graphene research and overcoming existing material challenge. So potential impact on quantum information science, that the addressing the unique attributes of graphene and its electronic characteristics could lead to significant breakthrough that would redefine the landscape of quantum information science and technology. Here, the reference I just used for these presentations, and thank you. If you have question, you can.
Thank you so much, sir. I would like to ask our session chairs if they have any questions for you.
Thank you for the
As I can
presentation.
see in one of the reference, like some of the reference slides, year is not mentioned for
Sorry,
the.
just a second.
If you see some of the slides, year is not mentioned in the references.
Oh, I'm working on through. That's why I'm saying earlier in the material things, I just use their references as like graphene. So I just use some of the metals which I showed in the slides to compare on the things.
Okay. Okay, fine. We can go ahead.
Professor Mutelo, do we have any
No
feedback or
question
any
from my
questions?
side.
Okay. Thank you
Thank you.
so much. Thank you so much, Mr. Farhan. Now we will go on to our next presenter. Our next presenter for this session is Cobus Kemp, presenting a paper on the title Security Implementations During the Development of Enterprise Mobile Applications, Lesson Learned. I request you, if you're available with us, kindly take over with your presentation, please.
Good evening. I am available. Can you guys hear me clearly?
Yes, we can hear you clearly, sir.
That is awesome. Can you guys see my presentation?
Yes, we can see your presentation.
There we go. Can I start?
Please, yes, please.
Good evening, ladies and gentlemen. My name is Cobus Kemp, as you heard, and I am from South Africa. My talk today will be about security implementations during the development of enterprise mobile applications and the lessons learned from this study. The paper originated from a study done as a master's on enterprise application security. The paper itself was specifically written to target lessons learned from this study. In short, halfway through the study, we realized that our outlook on security and how it should be implemented might have been a little incorrect, and we had to make a little small pivot. But that said, without further ado, let's get into it. We will briefly touch on a research purpose, look at an introduction on how we came to the research question, go over some literature review points, look at the research methods used, talk about the participants, go over the stats discussion, as well as finally reviewing the conclusion. And then we'll have a little talk about future work proposals. Our research purpose was to evaluate any and all security practices during the development life cycle of enterprise mobile applications, or like we call them EMAs. Another purpose of this research was to find ways of developing software with more secure processes and more secure strategies. When starting to look into the research problem, we found that data security might seem insignificant on mobile phones for the general smartphone user, people like you and me. However, it becomes way more important when managing enterprise data that could be very sensitive, especially if this data is being managed by these smartphones. We came to the question, does the development of EMAs that manage this data cater for the greater consequences of data breaches? We first started looking into software development methodologies. This included waterfall and processes surrounding waterfall. We then moved on to newer processes in the agile methodology space. This is where Scrum and more flexible processes and practices come into play, where clients want to be part of that journey and chop and change as they want to, whenever they want to. Going on from that, we looked into mobile application development and the different types of applications. We came up with consumer apps and enterprise apps. Consumer apps are the applications that we everyday people use and are usually available to the general public on something like an app store, for instance. Enterprise apps are normally designed and built for a specific enterprise or company to enable them to manage some sort of data or process. These apps normally run very much like enterprise software, but on a mobile phone rather than computers or laptops. Because of the increase in mobile application usage throughout the years, so did the need for security arise. The problem was that mobile applications were new and many different vulnerabilities existed, whether we knew about them or not. We started looking into these to identify what we need to prepare for, and we came up with 4 main categories of threats. The first being ubiquitous computing, which is the communication model of having access to information from anywhere at any time. You can think about this in a way of a cloud server and the interaction with it. The biggest risk with this was mainly Wi-Fi itself, but it opens itself up to some other security threats as well. BYOD, or bring your own device as a practice at a lot of companies, was also seen as a security threat, mostly because the mobile devices used in these practices were personal devices, and people don't normally secure their personal devices very well. So that's definitely a security threat. Third, we look at malware, one of the more well-known security threats. As with computers, mobile devices open themselves up to having apps that have malicious intent as well, whether we know about these apps on our phones or not. And then the fourth category is more like an umbrella category over some general security threats. And this includes things like device cloning, content falsification, and several different types of man-in-the-middle attacks. Moving on to the methodology, we first looked into a quantitative research approach, but quickly noticed that that wouldn't work for what we wanted and needed. So we decided to go with a qualitative research approach. The participants during the research were us as researchers, as well as interviewees from the selected organizations. Data was collected via case study and semi-structured interviews, and a thematic analysis was done that encompasses 3 main steps: open coding, category creation, and abstraction. From this thematic analysis, we developed a guiding framework for use during the development of EMAs. The participants during this study were organizations that developed EMAs either for themselves or their client use. We had a total of 9 different participants in 7 different case studies, and these case studies mainly focused on the following: the type of work the companies did, as well as their target audience, the different storage methods they used for data, their development methodologies, the different business and development practices they used, and security they implemented during every single of these phases. Looking at the data we analyzed, we could quickly realize that our idea about security and how it is implemented during the development lifestyle was a little bit incorrect. This is what I talked about earlier, the little pivot we had to make. From the data, we got answers such as security is important to us throughout the entire life cycle, every single phase. Security is very important to us in every aspect of our business because we work with clients and client data is very important, and the clients themselves as well. Security needs to be present in all phases of development, from the time of gathering requirements all the way through to end-to-end testing. All these answers led us to believe that the methodologies themselves don't really have security practices outlined, and that it's seen as something completely separate from the methodology itself. Because of the separation, we decided to create a guiding framework to serve as sort of a checklist. On the screen, you should be able to see this framework, or at least a part of this framework. And we'll go over 4 different aspects of security that this partial framework covers. These 4 aspects are environmental security, application security, development security, and data security. Environmental security encompasses the BYOD security practices, or the bring your own device security practices. This includes device setup and restrictions on the devices depending on the data classification, segregation of personal as well as enterprise data, containerized environments to create secure environments to develop in as well as to manage data. The 3 other aspects fall under what we call security planning, and they are application security. This ensures that any online application is secured via SSL certificates and HTTPS communication. It also includes user authentication, which can be strengthened via multiple factors of authentication, or as we like to call it, two-factor auth. Next is development security. This is generally a security analysis, after which a risk assessment is done to help decide what level of security is needed during the development, as well as for the application itself. Authentication for all developers and the use of secure third-party applications and services help develop in a secure manner. And when we move on to the final one, data security, which includes digital rights management, security measures for sensitive data, such as encryption, and development data always being secured in some form or way. This means normally when you have like databases locally on your computer and such. The framework we just looked at is a partial framework out of this bigger one that we developed in the original study, but it's a little bit out of scope for this discussion, so we won't be going into that. In conclusion, the following question emerged after looking at literature. Are various security issues adequately addressed during the development of EMAs? We conducted multiple case studies in the form of interviews, and results were analyzed to create a guiding framework. We finally realized that security relies on many different factors, and therefore it's unlikely to establish a universal set of strict security guidelines that apply to all of these different scenarios. This is why we came up with 4 primary areas that need attention when implementing security. These areas are environmental security, development security, application security, and data security. For future work, we might look into some of the following. Research that focuses on examining individual security vulnerabilities, but in more depth and more detail for a more targeted solution, not this encompassing solution that we currently have. And the findings of this could help develop training programs and different curricula to identify gaps in education, as well as gaps in the practice of software development itself, whether that's mobile development or software development. And finally, we could do something like an investigation into AI and how it is transforming mobile app development, as well as the security implementation during mobile app development. And that is it from me. Thank you very much for listening. And yeah, I'll open up the floor for some questions.
Thank you so much, sir. I'll like to ask our session chairs. Professor Muchello, do we have any questions?
Thank you. Thank you, Cobus, for your beautiful presentation and for unpacking the topic very well. I just wanted to ask, you mentioned that you're talking about security implementation during the development of enterprise mobile applications. Could you maybe share with us the type of enterprises which you mentioned in your case study, maybe an example of, and what type of services do they offer or they do on this mobile?
Yes, so we had 2 big banks that had, so I just want to close this. We had 2 big banks that we went to, both using in-house software that they created for themselves that needed to be very secure because they work with banking data. Another one was an agricultural company that create apps for their agricultural use, also in-house. And then we talked to, I think, 2 or 3 different bigger, what we call development houses that house developers, and they write applications for external companies for different uses depending on that client's need.
Mm-hmm. Thank you. You also mentioned that in your I was reading your abstract that despite the growing prevalence of mobile application, security considerations are often overlooked. and insufficiently addressed. So what contribution can you add on to the findings that you have so far when it comes to securing mobile development applications?
So I think the second future work we talked about kind of links into this. When people start developing programs, they feel to get this specific spec and need out there as quickly as possible for people to use. However, because of this need to get software out as fast as possible, people don't think about security, or even if they think about it, they don't think about it enough. And I think what I mentioned in the second future work, sorry, I'm getting to the point, the development of training programs to identify the gaps in specific the practice of software development. This could help companies employ the correct people, and those people knowing what needs to be done and how important security is, whether that's for enterprise mobile applications, whether that's for software, whether that's for normal everyday applications as well.
Right. Yeah, I just wanted to maybe a bit of contribution to the security features that one can also think of the regular auditing and monitoring security as part of the user, because as users of mobile application, we hardly do the auditing of our mobile. So it could also maybe be a part of the security features, where a continuous monitoring, where you monitor your app usage, your logs, and the behavior to detect unusual activity and security breaches earlier. That was just a suggestion. Thank you. That's just a beautiful study. Keep it up. Thank you.
Thank you very, very much. We'll keep that in mind.
Thank you, Professor. Professor Tarun Sharma, so do we have any questions from your end?
No, ma'am. It's a very good presentation, and in this, no question from my side. Thank you so much.
Thank you so much, sir. Thank you so much, Mr. Kemp. Now we hop on to the next presenter.
Thank you very much.
Thank you so much, sir. I would like to call upon our next presenter, Marisol Roldan Palacios, paper titled Squeezing Hidden Knowledge from Scarce Data, a technique tested on limited data of a language pathology. If you are available with us, I request you to kindly take over with your presentation, please. Ma'am Marisol?
I'm here.
Yes. Okay.
Give me a second.
For sure, ma'am.
Just a second. I can share my screen.
Yes, ma'am. Ma'am, is there any challenge while presenting?
No, it's
Yes.
problem with the settings. In this is the first time it's happening. Usually I can share.
I just request you kindly, please select the share option. It will give you multiple options.
Yeah. I pick up the share,
Okay.
but it's opening a window asking me for. It's not recognizing the application.
Ma'am, could you share us the PDF if it is not working for you?
This is strange because
No worries, ma'am. What I suggest is, could you log out and log in once?
okay, thank you.
It will be solved.
Yes.
Yes, ma'am. Okay.
Okay, let me try again.
Yes, ma'am, please. It's still not working.
No, it's send me to the security and privacy window instead of opening the.
No worries. Could you share the PDF with our team?
Yes, sure. I'm sending right now.
Meanwhile, we resolve this issue with your PDF. I'll just take the second presenter for the session. I request you, ma'am, to kindly share that presentation with our team. And meanwhile, we'll take up the second presenter. I hope that works
Okay.
for you, ma'am.
Okay.
Okay, thank you so much. So meanwhile, we resolve this issue. I'd like to call upon our next presenter, Muhammad Shahaziz Amir bin Sahmat, presenting a paper titled Technology Adaptation for Advancing Learning Quality Performance, Insights into Technology Assisted Instructional Design. Sir, I request you, if you are available with us, kindly take over with your presentation. So your audio is muted. One second. I request you to kindly unmute yourself, sir. Yes.
You can hear.
Yes, sir. Now we can hear you.
Can see the slide, my PowerPoint.
Yes, sir. We were able to see your slide in slideshow mode previously. Right now it's in the full screen wherein we can see the PowerPoint as well.
Okay, can I start now?
Please, please. Yes, please, sir.
Okay, hello everyone. Thanks to our moderator and our chair session. I'm Muhammad Shahazi Zamir, and I'm very honored to present on the topic Technology Adoption for Advancing Learning Quality Performance Insight into Technology Assist Instructional Design. So this presentation will explore how technology can be effectively integrated into instructional design to enhance learning experiences and improve educational outcomes. So, in today's education system, technology is no longer just an option, it's a necessity. But while we talk about technology in classrooms, we often overlook an important questions such as, are we using it effectively in instructional design? So teachers play a crucial role in shaping student learning, and research has highlighted the benefit of technology in enhancing learning quality. However, there is a limit focus on how technology should be structured within instructional design to truly optimize its impact. So this study aims to fill that gap by exploring how technology adoption can be implemented strategically to improve teaching efficiency, student engagement, and overall learning outcome. So we conduct a qualitative study to gather insight through data collection, analysis, and descriptive research. So our goal was to paint a clear picture of how technology adoption can enhance instructional methods and create a smoother, more effective learning experience.
So we are unable to see your presentation in the slideshow mode.
Oh.
Yes. Now we can see it.
Now, let's look at the key challenges that motivate the study. So in Quranic education, Taranum plays an essential role alongside Tajweed, Tahsin as-Saut, and Tartil. However, research shows significant gaps in the teaching and mastery of Taranum, especially among educators. One major challenge is that many secondary school teachers lack proper training in Taranum. So this is largely due to a lack of structured courses and limited exposure to this field. Without formal training, teachers struggle to deliver effective lessons, limiting students' opportunities to master the skills. Our study focuses on Sarawak in Malaysia, where this issue is even more pronounced. So Dato' Haji Ismawi bin Duit, an expert in Taranum, pointed out that the mastery of Taranum among teenagers and adults remains at a moderate level, while some informal class are available. Achieving true mastery requires highly skilled teachers, which is still lacking. Adding to this problem is the lack of research on Taranum education in Sarawak. Most studies come from Peninsular Malaysia, which means that local challenges and teaching methodologies in Sarawak have not been fully explored. So this gap makes it difficult to develop effective tailored teaching strategies. Additionally, many teachers still rely on traditional methods and do not fully utilize modern technology to enhance learning. So Islamic education teachers must integrate Quran recitation with Taranum to create a more holistic learning experience. Despite curriculum changes in Malaysia, many educators still struggle with effective teaching methodologies. Research suggests that engaging and innovative activities are needed to support better Taranum education. So now that we understand the challenges, let's explore our research approach. We adopt a qualitative approach using semi-structured interview as our main data collection method. Unlike structured surveys, semi-structured interviews allow for deeper conversation, giving us flexibility while capturing rich insight from teachers. So this method is widely used in community studies, as we know, because it uncovers hidden aspects of learning behavior and teaching challenges that traditional research might overlook. To ensure meaningful data collection, we build a relationship with participants to encourage open discussion, analyze response for key patterns related to Taranum teaching, present finding descriptively to offer structured understanding of instructional methods. Now, our study revealed several teaching methods commonly used in Taranum instruction, such as Talaki Musyafahah is the most widely used method, where teachers demonstrate the recitation and students imitate. Tasme is a student listen and repeat, reinforcing their learning. Takrar is a systematic repetition to strengthen fluency and recall. And demonstration, teachers actively show students how to apply Taranum techniques. So some teachers also use explanation, which is providing context before intensive practice, group learning, encouraging teamwork and confidence building, and discussion is helping students reflect on challenges and solutions. So ultimately, if we combining both traditional and modern approaches, leads to more effective Taranum teaching. Now, first, practical learning is essential. Method like Talaki Musyafahah, Tasme, Takrar, and demonstration remain the foundation of effective teaching. Second, repetition or Takrar enhance cognitive retention. Research shows that repeat exposure strengthens neural pathway, making learning automatic and long-lasting. So third is demonstration-based learning is highly effective. Just like in a medical or technical training, seeing and hearing Taranum perform in real time is far more impactful than reading about it. And finally, modern methods like group learning and discussions should not be ignored. So this method creates a more interactive and engaging learning environment. In short, while traditional methods are effective, teachers also should explore additional strategies to maximize learning outcome. So the conclusion, our research confirms that Talaki Musyafahah, Tasme, Takrar, and demonstration remains the core teaching method for Taranum. So these techniques provide direct guidance, reinforcement, and real-time correction, essential for mastering Quranic recitation. However, we also found that explanation, group work, and discussions also have a great potential to improve student engagement and learning outcome. So moving forward, teachers should adopt a flexible approach, blending traditional method with modern instructional strategies. So by doing so, we can make Taranum education more engaging, relevant, and accessible to future generation. Thank you.
Thank you so much, sir. Now I'd like to ask our session chairs, Professor Mutelo, do we have any questions for sir?
Thank you for the floor. Not really a question, but just a comment that the study is really relevant to globally because a traditional teaching has been a global issue that has been experienced by many, even us who are teaching in higher education. We still have we are still challenged. So this is really a beautiful study, and is relevant for us to learn from, and it contributes to body of knowledge globally. Thank you.
Dr. Tarun, do we have any questions from your end as well?
Yes, ma'am. Sir, you have used the flexible approach in your presentation. What do you mean by flexible approach? What kind of flexibility you are talking about?
Flexible approach is the teachers is not focus on traditional approach like they used to do. I know maybe teachers is very old school style, so they must be flexible in approach because student styles is different. So maybe the teachers also can improve their teaching strategies more flexible to enhance the student learning.
Uh, right now, there are two things that are common in current scenarios. First one is student-centric and second one is teacher-centric. As far as the traditional approach is concerned, what do you mean by the traditional approach?
Okay, traditional approach is like if we in my studies or in my this research, traditional approach is like a talaki musyafaha. That is a traditional approach where the teacher one by one to their student, not in group or any don't include any activity that interactive. Just one by one, teachers reciting the ayat or the Quran, and then the student listen and recite in front of their teacher. So that is a traditional method that they use in teaching of Taranum. So my suggestion is to improve their teaching, include some other, or combine traditional method with the modern modern approach, such as a group work, use a YouTube or use nowadays we have YouTube to we call it to help teacher to teach the student. That's what I mean lah, Prof.
I think you want to say that the interaction will be the classes or the communication between the both of them, either the student or the teacher is uh, interactive, or we can say the two-way communication, right?
Yeah, just uh, not many communication will happen if we have a traditional, if we use a traditional strategies, not have many communication in there. That's why I suggest to improve the strategies to the teachers to more communicate to the
Okay, you just said you just told about the YouTube, right? So in that case, if a teacher is using YouTube, so in that case we can say that it is an interactive teaching, or we can say that it is a modern approach.
Sorry, Prof.
You have mentioned YouTube, na example of YouTube for
Yes.
modern approach, like right. So in that case, just I want to know whether if, for example, teacher is using a YouTube video, can we
Okay.
consider it as an example of modern approach?
Yes, yes. For Islamic education, YouTube is some uh like a modern approach, Prof.
Okay, thank you so much.
Okay, thank you, Prof.
Thank you so much for your presentation, sir. Now I would like to call upon our last presenter, Ma'am Marisol. Uh, if you have rectified the issues as per what she has said, I request you to kindly take over with your presentation, please.
Can you see my screen?
Yes, ma'am. 1 second. We can, yes, we can. However, it's not.
In full screen?
Yeah, okay. We can see it. Yes, slideshow. Yeah.
Okay. It's
Yes,
okay now?
ma'am. Yes.
Okay. Let me start. My name is Marisol Roldan Palacios. I'm here to present the work Squeezing Hidden Knowledge from Scarce Data, a technique tested on limited data of a language pathology. Let me start by going into the context. We see that each analysis running on large or small data has particularities and faces constraints. A representative example is in small data, where models designed to support large data is fed with little data. In a context where little data is not exactly defined, where small data scarcity, limited data, and even low resources share the notion of low-scale data. In the particular case of lack of data, many reasons can cause that, even the subject of study. But let us see what lack of data here means. Lack of data means no more data is accessible, even unlabeled, in a context where the use of synthetic data is not an option. And large language models are impractical too. Let's see then the problem definition. We work limited data as a critical aspect, where large language models are impractical, where the same object of study contributes to the little availability of data, preventing the use of synthetic data, since the addition of noise or changes can produce uncertain outcomes. A likely risk when disorders in language are the subject of the study. Then we come to the research question. How to squeeze hidden information from small data? To reach a solution, we use alternative methods that are explained in the proposal. We develop a technique to process and evaluate data to increase information extracted from scarce data. Here, attributes are expressed and worked as trajectories. And They are further examined by pairs by a relation that we call proximity. And the results are evaluated by customary learning methods. The efficacy of the proposed approach is tested and validated in language samples from individuals affected by brain injury. As a baseline, we consider the discriminative capacity of direct and normalized raw data. Proceeding with the background, we have the relation of proximity we're introducing, which is the base of the technique we work on, developed on the idea that attributes through consecutive time points can depict trajectories, such as in a narrative task. Here, in brief, are the steps to compute it. But better, we show them while explain them. Once trajectories are ready, we relate them by pairs. The polygon that they delimit is divided into triangles. Then centroids and midpoints of those triangles are calculated. And the area between the polygon curve that form these points defines the proximity measure. Let us describe the steps of the complete technique. The narrative samples in the first for the specific task are extracted. Then the samples are segmented based on chunks of the participants' interventions to form accumulative instances. The attribute values are calculated. Then trajectories and generated unrelated by proximity to examine the adjustments in their relation. And the proximity scores fit learning methods to the discriminative capabilities will help to characterize the studied language. Let us enter to the specific experimental setting that involves the corpus, DocBank website, host TBI Bank, providing data to study language alteration caused by a traumatic brain injury. It encompasses the recovery stage and different narrative tasks. For the study group, we considered the retelling task of the Cinderella story. And for the control set, we looked at generative story based on the runaway picture, with a sample size of 42 instances in average. Working lexical attributes in groups. The first, we refer to as L1, contains variables such as MLU words that denotes the mean length utterance in words. The second, L2, that contains types of attributes that are known as open and closed class words. And L3 with noun and verb relations. And again, with a sample size about 42 instances. Going directly into the results that we summarize in tables, observe that based on the studied feature sets, we explore pairs of attributes to examine the effect of the introduced relation. That is, our interest was to understand how the relation of proximity influences the attributes either increasing or decreasing their contribution in characterizing the examined language. Observe that relating total word attribute to the rest in L1, we found a consistent satisfactory effect, which means that the highest F1 score totally corresponds to the evaluation of the proximity measure for both algorithms, naive Bayes and simple logistic. In L2, we observe even more consistent behavior than in L1, relating the ratio of open and closed class words to the rest of the attributes. But let us proceed to the third set of attributes, L3, where we found the pair, the ratio noun verbs with the percentage of all nouns in reference to all words, where the highest F1 value is for the normalized base with naive Bayes and for the direct base with simple logistic. Let's see the distribution for proximity values in box plots. On the left side is a representative sample of the distribution pattern generally produced by proximity processed data, with a clear separation in the results between the control and the study groups. These relations allow to discern a likely modification in the use of closed words in the study group. On the contrast, on the right side is the distribution for the remarked pair in L3, where proximity has had the lowest FUM values for both algorithms that can be explained for the significant overlap in their distribution. In short, within our conclusion, we have that the results suggest that the proposed approach can raise extraction of knowledge from attributes, that the technique provides a way to train language adaptation handling hard constraints in data. For the work coming, we will prove the technique on another type of attributes and for different time points along the recovery stage analyzed. We recognize the support of CONACYT institution in Mexico, and we thanks to ICICT. Please, questions.
Thank you so much, ma'am. I request our session chairs if they have any questions for ma'am, please kindly go ahead with them. Professor Mutelo, Professor Sharma, do we have any questions?
No, ma'am, no question.
Okay, we don't have any questions from Professor Sharma. Professor Mutelo, do we have any questions from your end?
No question from my side. Thank you.
Thank you so much. Thank you so much, ma'am, for presenting. With this, we come to the end of our session. With this, we come to the end of our session. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of this conference. We'll be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within the 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2025. I also like to thank our session chair, Professor Mitero, Professor Sharma. We have a token of appreciation from our end for both our professors for being the chair of our session. I would like to display the certifications for our session chair. Before we close, this is the certification for Professor Mutelo. Would you like to say a few words while closing this session, Professor Mutelo?
I just want to say thank you for having me. Thank you for having me as a session chair for this conference. I really appreciate, and I would like to say that I've learned a lot and looking forward to the next session. Thank you.
Thank you so much, ma'am. And this is a certification of appreciation from our end for Professor Tarun Kumar. Sir, would you like to end this session with your words?
Thank you so much, ma'am. The presentations of all of the presenters are very good, and all of the papers or all of the presenters having provide a very informative presentation. They give the very good presentation. And finally, thank you very much for providing me this opportunity. Thank you so much.
Thank you so much, sir. Thank you all for being a part of this session. I just request you to kindly switch on to your cameras for a quick snapshot of our virtual session. All the presenters and the chairs, we request you to kindly open your cameras for a quick snapshot. Okay, now we'll take a quick snapshot. One second. Thank you so much. Now I request all of you all to kindly log out. We'll meet you in the next session as soon as possible. Thank you so much.
Thanks, everyone. Have a great day further.
Thank
Thank
you.
you.